Welcome to CAE Bootcamp. In our last two modules, we have discussed about the 2D machine and introduction to HyperMesh. In these two parts, we have learned how to operate the basic things in HyperMesh. Say, for example, importing the file, cleaning the geometry, editing the geometry. Along with that, we have learned mid-surface extractions. What are the different options which are available in HyperMesh to extract the mid-surface? With this, we also done the 2D meshing. By extracting the mid-surface, we done the 2D meshing and we did the remeshing also, and the respective quality parameters, what the industry is maintaining for the elements. We have discussed all these things. In continuation to these modules, today we are concluding this bootcamp with a 3D modeling, that is a 3D meshing. In this module, we are going to discuss how the solid geometry is, how to check the solid geometry, how it looks. When the geometry, when you are imported, how the solid geometry looks like. Then along with the solid geometry, I'm going to discuss about the volume tetra mesh. See, volume tetra, how to create the tetra elements by using the geometry or by using the elements. These two things we will discuss. Then after creating the tetra elements, as usual, we need to do the remesh and respective quality parameters for the 3D elements also. We'll do one by one. The image what you are seeing in the screen, this is the CAD model. I have taken one simple engine component where you are seeing, this is the CAD file. The circles you are seeing here, these are the mounting location of the engine. These are the mounting location of the engine where the bracket is going to sit. On this bracket, the engine is going to sit. For the same model, I have created the tetra mesh. That is, tetra mesh means, like, first I will show in the two ways. First, by using the geometry, how to create the tetra elements. Then the second one, by creating a shell elements, how we can get the solid elements or tetra elements. We'll do your first 3D modeling using Altair HyperMesh. Next, we'll move on to the contents of this module. See, I'm beginning this module with the solid geometry, how the solid geometry, then volume tetra, then all these things we'll discuss one by one. Basically, how the solid geometry looks like. See, the image what you're seeing here, and these ones we have learned, there's gray points. The gray nodes are called the points, and the bonding surface, the green lines. In the 2D modeling, we call it as a shared surfaces. Whereas in the solid geometry, we call it as a bonding surfaces. Then these two surfaces are going to connect. That is called it is represented in a red line, no? That is the fin surfaces. So basically, the solid means the geometry will not having any discontinuities. The geometry will not having any missing surfaces. Then those geometry will come under the solid CAD or solid geometry. The geometry is enclosed by completely volume. See, most of the cases when we are using any design softwares, we work with the solid CADs only. We will work. Then for our when it comes to the CAE software, we are deleting that solid and we are carrying the machine on the surface. Like after deleting the solid, the rest of the surface what we get on that surface or top of that surface, we are going to create the solid elements. We'll see how the solid geometry looks like. See, this is how the solid geometry looks like. This is how the solid geometry looks like. See, as you can see here, I have just switched on the points. The yellow line is there, no? This yellow line indicating these two surfaces are merged. These two surfaces are merged. And the green line, it is the fin bonding phase, or we can say it as an adjacent surfaces. This line is sharing between the two surfaces. This line is sharing between the two surfaces. As you can see here, there are three parts in this solid. As I said, these solids can be divided into different surfaces or else different component also it belongs. See, complete this, I'm switching on only this CAD. See, only this CAD I'm switching on. We can move these surfaces to the different collectors also, or else you can keep it in a single collector also. See, this is how we know how to switch on the CAD. Here we have learned. And one more thing, see, This button is we are using for transparency option. I'm just reducing the transparency. Okay. Now you can see the complete volume solid. Now you can see the complete volume solid. Here, this geometry contains solid in it. You can see the green line which is highlighting. The green line which is highlighting. No, you can see this represents this CAD is having solids. Let me delete this solid, but it will, after deleting the solid, it will not affect anything to the CAD. After deleting the solid also, we can create the elements. If required, if it is a 2D modeling, we can extract the mid surface and we can create it. And we know the delete option is available in the F2 button. Click to this drop down, and in the next page, solids is available. Here the solid is there. Click on the solid, come back and select all the solid. See, now it is highlighted, no? It means it is selected. Say these two components are selected in a single color, but here if you see this component is having some, you can see some graphical display here. It means this component is duplicated. Say delete entity. See, as I said, after deleting the solid, just observe. See this green line highlighting. After deleting the solid, there will be a normal green line. There will be a normal green line. You can observe this is how the solid geometry look like. But after deleting the solid also, it will not affect anything to the CAD. You can go for, I'm just masking the surface. The masking option is available in the F5 panel. Go for the surface and you can mask. After masking, you can see there is a halo inside. It is halo inside. It means now this geometry doesn't having any solid. So this is how the solid geometry looks like. And by looking at the CAD only, you can define whether this component is having solid or not. Then we'll move on to the other things. What are the different elements are available to create any solid model? Here I have mentioned the 4 different element types, element shapes. One is a tetra element, pyramid element, hexa element, and the penta element. See, this tetra and the pyramid elements will comes in the tetra meshing. Hexa and the penta elements we are using in a hexa meshing, or we can call it as a brick meshing also, we will call it. See, I'll show these elements, how it looks after creating. The stand which you are seeing here, this CAD stand which you are seeing here, let me show only the elements. I'm keeping for only the elements I'm keeping. Now, let me mask few of the elements. See, I'm masking few of the elements, or else let's mask only these 4 elements. See, when I go for clicking the element, no, see, it is highlighting towards the bottom. That means you can see the highlightation. It means it is a solid element. Mask and reverse. Okay, we'll mask these elements and we'll reverse this one. See, you can see it is in solid geometry. In the last module, we have seen how the shell element look like, Now, if you can keep it in the wireframe and observe the things, see, this is how the solid elements look like. It is a complete cube element. It look like a complete cube element. Switch on all the elements. Now we'll see how the penta element looks. See, the penta element means that is a 3D element only, triangular element only, but a solid trias. Say reverse, see, this is how the penta element looks. This is how the penta elements looks. See, you can go by adding the nodes and you can check this one. See, if you are going by adding and looking at the node, you can see. And you can count the node. See, here are the 3, here are the 3. There are 6 nodes are there. There are 6 nodes required to define a penta element. There are 8 nodes required to define a hexa element or brick element. See, for this brick element, now we can call it as a hexa element, brick element. These are the different terminologies which we call it in the industry. You can add, it requires 8 nodes. See, keep it in a wireframe and observe this one. And you can count also. These four side noded, and here also. It means for penta element it requires 6, for hexa element it requires 8 nodes. Whereas we did in the module 2 for the triangular element, how we did by using a 3 noded element and the 4 noded element. Likewise, in hexa also there are the different shapes, but these the hexa, penta, pyramid and the tetra, all these are 3D elements only, but different shapes. There are the like when we are telling, no, observe what are the words or what are the terminologies we are telling, so that it will be very easy to understand the things. We'll see how the tetra elements looks like. I'm showing it in a different hypermesh. As you can see here, this is a tetra element. If you go by selecting any solid, say mask and reverse. Okay, here the solid elements are not yet generated. It's okay, I'll show it. I'll create it and I'll show it. Okay, then we'll move to the directly we'll create a tetra element and we'll see how it looks. What is volume tetra elements and what are the elements we can create? Using in volume tetra elements, we can create the tetra elements and the pyramid elements also we can create. This volume tetra option is available in the 3D page. It is available in the 3D page. As the name indicates, volume tetra mesh. To do the volume tetra mesh, our geometry should be completely enclosed. See, there is a difference in creating a 2D elements and creating a 3D elements. When we want to create the 2D elements, we require only the surface. By having only one single surface, you can able to generate the elements. But there is a different case to create a tetra elements. There are two ways to generate the tetra elements. One by going with the geometry, or second option by going with the elements also we can do it. First, I'll take how to generate the tetra element by using only the CAD. I'll show it. Okay, the image what you're seeing here, the same CAD we have shared with you guys. And as I said, in the module 2 we have discussed, before starting any machine we should go thoroughly with the CAD. Why? Because to know the missing surfaces or duplicated surfaces, so something like that we need to check it. Now my CAD is having some missing surfaces. Why? Because I can see there are red lines in the CAD. In between the CAD, I can see the red lines. Keep it in a shaded mode and you can observe. See, there are 3 lines are there. Now, I'm not going to fill any lines. Why? Because I want to show how the volume tetra mesh works. I'm going for the 3D. See, this is the 3D page. In the 3D page, go for the 3D page. Check for the tetra mesh. Here the tetra mesh sub panel is available. Click on the tetra mesh panel. You can see this is sub panel. Here in the third option, I can see the volume tetra. In that volume tetra, I'm clicking to the surfaces. See, here it is asking me enclosed volumes. Just see, I'm trying to select the surfaces. It is not selecting. You just try these options. See, it is not selecting. Only the single surface it is selecting. Even though if I'm trying to add all the things, I'm not able to generate any elements to this. Why? Because the geometry is not enclosed. Enclosed means all the complete geometry shouldn't have any free edges. That means my geometry should not be having any red lines. All these geometry should be connected. All these surfaces, points, lines, everything, it should get connect with the adjacent surfaces or adjacent line, like that. Everything it should get connected. And we have learned how to create the surfaces. Either you can go by going to the surfaces, choose the lines. See, by choosing the lines also you can able to generate the surfaces. So you can drag this one, select the line. See, observe this one. Just by clicking that line, you can able to get the surfaces. Either you can go by going to the surface also. You can correct it. See, it has created. And one more option we have learned, that is 2D. By going to the ruled option also, you can go by creating its surfaces. Here I am keeping only surface only. Here I am not requesting for the elements. I am requesting for the surface only. Now choose the first line and choose the second line. When we are choosing the line, it should be proper way. Say create. Okay. The surface is created. Now again, keep it in a wireframe mode and check for the missing surfaces. Here I'm not seeing any red lines. See, when you are looking for the CAD, please be patient and check for the CAD. Okay, here we can see one more free edge is there. So we'll create the new surface. Now keep it in a wireframe and check for the CAD whether it is having any free edges. Here I'm not able to see any free edges. I'll go by creating one collector. That is, I'll create shell. I'll create one collector called shell. Say created it. After creating this one, see, now you can observe in the right corner of the HyperMesh, you can observe engine mount. Engine mount collector is there. After creating this shell collector, the existing collector will appear here. And you can see in the model tree also, now it is only one component is there. Now it is only one component is there. If you create it, no, you just observe. See, the current collector is reflecting here. And the collector which we have created just now, it is appearing here. Here also you can see the collector, and this is the existing collector. Every time it will change. Now I have created a new collector called shell, so it is coming here. But after this one, if you wish to create any new collector, the existing new collector will come and sit here. That means every time when you are creating a new collector, it will become a current collector. New collector will become a current collector. Now we have cleared the geometry. Again, I'm going for the 3D page to create a Tetra mesh by using volume mesh. I am going by volume Tetra. Now select the surface. See, now I have created a new surface where it is missing. Now I'm coming back to the 3D mesh again. In a single click, complete component is going to select. You click on anyway, just select this one. See, complete surface is going to select. Now what I'm going to do, I'll just say create or mesh. But here one thing you need to observe. Here I have given 4 mm. Here I have given element size as 4 mm. In the module 2, we have given an element size. No, in the F12 panel, we have defined some number, that is the element size. According to our element size only, the elements will get created. So like this, the element size will matters more, because this is a major parameter and important parameter where we are going to define. Based on this number only, the complete component elements are going to create. Here I have kept it as a equilateral triangles are mixed. It means the 2D mesh how you want, the 2D type. In the 3D, there is an advantage. Either you can go by using in 2D, you can get the 3D, or else by using in 3D elements, you will get a 2D elements also. So it is asking me which you want, like you want by only trias or only odd trias, it is asking. I'll keep equilateral trias. In the 3D type, it is asking tetras. I am keeping tetras only. I am keeping. Here it is asking me first and the second order. First, I'll go by showing how it will work for the first order. See, I'll just choose the surface and say mesh. It will take few seconds to complete the mesh, and it will work based on your system configuration. If the system configuration is very good, you will get the mesh very easily. Now you can observe in the status bar, it is showing. Okay, now it is ready. See, the collector which I have created just now, it is in the pink color. My elements are generated, or the elements which I got, it is in the pink color only. Now I got first order tetra elements. We'll see how it looks. Okay, this is how the tetra elements, and all the elements which I have created here all are equilateral trias. I'll go for F5, select a few elements and say mask. and reverse this one. See, you can see inside also elements is there. Inside, we are not seeing any halo elements. See, there is a difference. See, this is this 2D elements mesh. Mask this one. You can see inside it is halo. Inside this is halo. It is just the 2D layer. It is just a 2D layer. Whereas here in this component, we can see inside also we have created elements. Inside also we have created elements. This is how the 3D element occupies. In the 2D elements, just we will wrap the 2D elements on top of the surface, on top of the CAD. But when we wish to create the 3D elements, inside also it will occupy all the space. It will occupy all the space. You can able to see, no, it will occupy all the space. This is how the volume tetra mesh works. But there is a disadvantage using in volume tetra mesh. Why? Because sometimes what happen here, you can see how the element distribution is. You can see the distribution of the element. It is not properly aligned, and we are not having control. Like we cannot control manually in the surface. Why? Because in a single surface, complete CAD is going to create the elements. But we can, if I wish to create R trias, means that is not possible. This is one disadvantage using the volume tetra elements. But how to overcome this one? How to overcome this one means by going with the standard tetra mesh, we can overcome this one. In the standard tetra mesh, wherever we want, we can create the R trias. Wherever we are not required, we can go with the normal trias. And I said the first order and the second order element, if we go for the shift F2, that is to create the temporary nodes, I'm just going by adding the temporary nodes. See, you can see the nodes only in the corner. You can see the nodes only in the corner of the element. It means this is a first order element. Let me add, say this is the first order element. I'm going to clear these nodes and I'm going to delete all the elements. Select these elements and delete all the elements. Set delete entity. Now again go for the 3D page, volume tetra mesh. Here I'm keeping the second order mesh. Choose the surface and mesh this one. See, in the first order mesh, example I'm saying, for this component, if it is taking 100 nodes, means in the second order, it is going to increase. Why? Because in the second order elements or in the parabolic elements, the mid node, it is going to create. How we learned in the 2D meshing. Likewise, in the 3D also, there is a difference in the node by creating the first order and the second order nodes. See, the mesh will not change. Mesh will not get changed anything. Just I'm adding the nodes. Observe, please observe. There is an increase in the node. See, we can see the mid node between the two corner nodes. We can see one more mid node between the two corner nodes. This is the first order and the second order elements. So clear all. Now we'll move to our next slide. Okay. This is what we have discussed in the volume tetra mesh. Then we will move to the standard tetra mesh. And I said, well, the advantages of using a volume tetra mesh, it will avoid the different size of adjacent elements. It means we can have a control over the mesh. We can control the mesh by selecting the surfaces. We'll do some standard tetra mesh using the same geometry. Okay, here what I'm going to do, I'm deleting all the elements. Either you can go by selecting the elements or come to the elements, say all, set delete entity. Now all the elements are deleted. We have deleted all the elements. Now our task is to create the standard tetra mesh. If I go here, you can see the first option, that is the standard tetra mesh. Here it is asking me elements or component. See here, first I'll go with the elements. See, why I'm going for the standard tetra mesh? The basic reason is, here I can see some of the curved faces is there. No, here I want the R trias, that is 90-degree trias. Why? Because here it may This hole may represent the bolt hole. We are not sure what it comes. See, you can see, and after creating the R trias, you can see the how the distribution of the elements, it is neatly aligned. It is neatly aligned. To capture the any curved surfaces, we need to go with the rectangular trias only or 90-degree trias only. Then only we can capture these things. You can see the difference. Here I'm going with the equilateral trias or normal trias. See how the distribution of elements is. How the distribution of elements is. To avoid these conditions. To avoid these conditions, for the curved surfaces, we are going with the R trias only. So choose this surface. See, where and all you want, we can control the mesh. See, we can control the mesh by selecting the elements wherever and how the elements we require. We can control over the mesh. So I can control the mesh. See, here and all I want the R trias. As I said, choose the surface and give the element size. Based on the element size, it will work. But if I come here, no, here I don't want the R trias. So why? Because see, using a R trias all over the component, it will make the component stiffer. So what I'm going to do, only for the curved section, I'm using the R trias. The other than that is the flat surfaces in the sense here. See, for the surfaces like this, I am going with the normal trias. I'm going with the normal triangular elements. See, like this, you need to choose. See, why I'm choosing like this? No, this is only the project requirement. And this is the CAE industry is following to create the elements. So here, for the curved surfaces, we are going with the R trias because of the good element flow. And in the normal surface or planar surfaces, we can use only the normal trias. So we'll mesh complete this one. Okay, in a single stretch, I have meshed everything. Okay, I have meshed everything. You just observe this one. Okay, we have meshed everything. Here, before going to the 3D Tetra mesh, what I am going to do, see, every time before creating any solid elements, if you are using in 2D elements, you need to clear the quality parameters for the 2D elements. That is, in the same F10 panel, you need to clear for the elements. You need to clear for these elements. You need to clear. I'm clearing for 1.5. Save failed. See, in the module 2, how we have discussed no? Likewise, we need to clear all these elements. So how to clear? I'm showing it now. See, I'm clearing for 1.5. Go for F10. Now check for the length. Now it is not failing for 1.5. Now we can move for creating a solid. So before creating a solid, I need one more collector. I'm going to create a new collector for the solid element. See, I'm going to create a new collector. The new collector will come and sit here. That will make as an existing collector. Now I have created new collector. Now I'll go for the Tetra mesh. Please observe. I'm selecting all the elements and I'm asking to mesh. Here I'm keeping to remesh. Okay, mesh this one. See, in the status bar, you can observe the mesh is not enclosed. Why? Because to create any tetra elements, the mesh should completely enclosed. In the volume tetra mesh, we have seen the complete geometry should be enclosed. No, likewise, to create a standard tetra elements, here you need to have the complete volume mesh. That means it is showing the mesh is not enclosed. This indicating our mesh is having free edges. So how to check the free edges? I just switch off the CAD, go for Shift F3, say preview equivalence, say find edge. Here we can able to see, the red lines. This is one of the major quality check which we need to do before creating any solid elements. Even though if you are keeping the free edges, the tetra the solid elements will not get generated. So how to delete these things? How to delete these things? Go for F3 and do equalencing. So by doing this one, you can connect the elements. I'm just connecting the element. Why? Because the geometry is not enclosed. To make the complete volume, I am going to merge this one. I am going to make this as a complete volume. I am going to make this as a complete volume. Okay. Since the distance is very less, so I am merging the nodes, or else if the distance is more means go by creating a elements. Go by creating a elements. Here I'll check the distance. Here it is 1.7. I'm not going to create the elements. I'll just merge these two elements. We'll check in the some other area. Okay, say unmask all again. Again, I'm checking for the free edges. Okay, still I'm finding the edges. So I'm keeping only the edge elements and I'm taking the adjacent of these elements. So we'll merge these elements too. Take these elements. Or else see, here I'm merging the node. That is one option. Either you can translate the node to pass the quality of this one. See, like this also you can do. Okay, here I'll create a new two elements. Okay, I have created a new elements. And here also, I'm just taking this node to here. Okay, now say unmask again. Shift F3, delete edges and find edge. Still, I can able to see the edges. That means the mesh is not completely enclosed. Mesh is not completely enclosed. Now, if you go here, say find edge, observe in the status bar, no edges were found. Selected entities may enclose a volume. Selected entities may enclose a volume. That indicates your mesh is completely closed. So we'll move how to create the stranded tetra elements. Come back to 3D page, select the elements and say mesh. Now it will take few seconds to create the tetra elements. Okay, now the tetra elements is created. Now switch off the shell. See, on the same collector, on the same plane, on the same layer, the solid elements are going to create. The solid elements are going to create. You can check it by masking the elements. You can check by masking the elements. Select the elements. See, it is not hollow. It is not hollow. It is created. So elements are created. So this is how you can create a standard tetra elements. If you want to create the standard tetra elements, the mesh should be enclosed. If it is in volume tetra, geometry should be enclosed. This is the two main difference between the creating the two tetra elements. Now, in the solid tetra mesh, you can see floatable and the fixed trias. These are the two important things you need to see the difference between floatable and the fixed trias. You can see this image. Floatable trias means first you are creating a shell elements. After creating or after generating the tetra elements, if you are keeping the floatable trias, the triangular element may be diagonally split like this or diagonally split it like this. So when we are creating the tetra elements, don't keep the floatable trias. Why? Because sometimes what happen, you may forget to create the 2D elements. That time it makes a problem. So for this is the reason, always go with by creating a fixed trias. I'll show where it comes. See, in the same tetra mesh, here if you go for the remesh option, here the fixed option is there. No, it should be always fixed only. Don't change this. Keep it as a fixed only. This is the difference between fixed and the floating trias. Now we have created a shell elements. On the top of the shell elements, we have generated the 3D elements also. Now next part is the remeshing. You can ask me why to do the remeshing for the solid elements. Even though These elements are created by using an 2D elements, but if required, we are going for remeshing. But why we need to go for remeshing means, I'll tell you before going to the remeshing, let's have a look into the quality checks. Likewise, how we did for the 2D quality elements, here also you need to check the quality for the 3D elements also. So what are the main quality checks which we do for the tetra elements means, the major one is TET collapse. TET collapse means there is a defined formula. Based on this formula, it will work height multiplied by 1.24 divided by the area of the triangle. It will show some value. That means here I'm giving as a 0.1. It will work according to this value. If the triangular value is less than my parameter value, then it will show as a failed elements or TET collapse are failing. This is one of the major quality checks which we do when we are checking for the quality for 3D elements. Likewise, free edges also we will check T edges and duplicates. Duplicate means sometimes what happens, the same elements are generated 2 times. At the same element, if you are carrying, no, just say, just taking one example, just assume you are having one box, and inside that box the same weight, if it is adding means the mass will get double. So for this is the reason we are not supposed to carry any duplicate elements. So these are the major quality checks we are doing. First we'll see the quality checks, then we can come for the tetra remeshing. Now I am keeping only the solid elements. In that solid elements, go for the functional key F10. If you go for the F10, here I'm checking for TET collapse. Click on this TET collapse and make this as to 0.15. Give the value. Check for the TET collapse. You can see there are many elements are failing. Let me make this 0.12. See, 143 elements are failing. So how to correct the TET collapse means, please observe one thing. When we are clearing the quality for the 3D elements, that too when we are clearing for the TET collapse, please don't go by translating the node or increasing the height or increasing the distance between the two nodes. Don't do that. Why means, after it may come out of the geometry deviation. Geometry deviation is not accepted. That will not comes under in the quality check. So we should be careful about the element should not come out of the geometry. That means, see, within that boundary only, my node is here. But sometimes what happen, to clear the quality parameter, if you are moving this node like this, it is not acceptable. Why? Because it is came out of the geometry. So for this reason, we are not supposed to change, or we are not supposed to move any node out of the geometry. But how to correct the quality means, just by going the remeshing option. I'll show. Unless it is not done by the remeshing option, then only the manual corrections comes. I'll go for F10 again. Check for the TET collapse. Now it is showing 143 elements. Say save failed. Switch off the CAD. Go for shift functional key F5. Retrieve the elements back. Say mask and reverse. Okay. You can see these are the elements which are failing for the TET collapse. And taking the adjacent of these elements, mask the shell elements, that is the 2D elements. Then again tetra mesh, remesh I'm going. Here I'm keeping fixed only. It should be fixed only. Select the elements, say remesh. Just remeshing means how we are doing in the FL panel, keeping the elements. Likewise, here also, just by going the elements, select the elements and ask for the remesh. What the remeshing will do, no? It will try to adjust the element within that boundary only. Within the 2 rows of this boundary only, it will try to create the new element. But it will not make the element to come out of the CAD. It will not do that. For doing a remeshing, it will take few extra minutes compared to creating a new elements. Let's switch on all the elements. Again, we'll come back to the F10 panel. Check for the TET collapse. Now it is showing 46 elements are failing. So again, you need to do like this only. At least 2 to 3 times, you need to do the remeshing option. Then only you can go by translating the node. So here now these elements are failing for the TET collapse. Again, I'm going and remeshing these elements just to have a good elements with the software option only. Okay, now the elements are ready. Here it is showing every time, it is showing how many times it is going to regenerate the elements. Every time it will show, say unmask. Now F10 again, check for the TET collapse. Now 14 elements are failing. Just observe the consistency of element. First it is 143. For clearing a 143 element, it will take so much manpower, so much it will require a time. We need to translate manually. But within a shorter time, within a few minutes, if it can be cleared using a software only, it could be a good way to proceed the mesh. Now 14 elements are failing. This time I'll show how to create it, how to clear it manually. Okay, now these elements are failing. I'll show how to clear this manually. I'll show for this element. Now come for the F10, click on this element. See here the TET collapse is 0.15 it is showing, 115 it is showing. Now I'll go for F4. I'll select this node and I'll choose this plane and I'm giving the value as 0.01. Say translate. Let me give 0.05. Say translate this one. Now go for F10. Check this one now. See now it is decreased. Why? Because I am decreasing the height of this triangle. Now what I need to do? I need to increase this one. Now F10 again. See now it is 0.12. So still we need to increase little bit. Now check it. Now it is, the TET collapse is clearing. If you click on the TET collapse now, see the adjacent element, it is showing. This element, it is not showing. Why? Because we have just cleared it manually. Again, go for Shift F4. Select these nodes. Increase the height of this triangle. Okay, now it is 0.16. So this is how you need to clear the TET collapse manually. There are 14 elements are failing. We have cleared the 2 elements manually. How to clear it? By going the remesh also we can clear it, or by going the manually also you can move it. This is how the remesh work, and this is the quality parameters which we maintain for the 3D elements or triangular elements. And I hope you understood the things which we have discussed, which comes in part of the 3D module, starting from correcting the CAD, creating a volume elements, and what are the different elements which are available in HyperMesh to generate the 3D elements. And we have learned how to create the standard Tetra elements also we have learned. I hope you understood this video. Thank you.